So let me welcome you, or to all of you. I'm very proud to present you our panelists on today to the session called AI in Science and Engineering. This is the room number 3. And we have very interesting people here. First of all, let me introduce you, Virginia Yannibelli. I will give a short description of your career, of course. So Virginia is a scientific researcher at CONICET, National Council of Scientific and Technological Research from Argentina since 2013, member of the ITESM Research Institute from CONICET and UNICEN since 2005, and professor of the Department of Computer Science at the Faculty of Exact Science of UNICEN University in Argentina. Received a PhD degree in computer science degree at UNICEN University, Argentina, in April 2009, and systems engineer degree at the same institution in March 2005. Her research areas include artificial intelligence, evolutionary computing, heuristics, optimization, machine learning, data mining, and knowledge management. Welcome, Virginia. Thank you very much for being here.
Thank you very much for the invitation.
Yeah,
thank you very much for the invitation.
Thank you. And let me welcome as well Lourdes Martínez. Lourdes is a computer systems engineer and doctor from Tecnologico de Monterrey. She's a research professor in data artificial intelligence at Universidad Panamericana and head of the computing area at the Faculty of Engineering. She has the distinction of rank level 1 at the National System of Researchers here in Mexico, the National Council of Science and Technology. She's authored more than 35 international journals and conference publications, 3 book chapters, 5 books in the area of artificial intelligence, and she's member of the board of the Mexican Society for Artificial Intelligence. She has been guest editor in different special issues of international journals. Her main research interests are artificial intelligence applied to healthcare and user modeling, as well as ethics for artificial intelligence. Welcome again, Lourdes.
Thank you very much for the
invitation. Let me introduce Raúl Monroy. Raúl Monroy obtained a PhD in artificial intelligence in 1998 from Edinburgh University under the supervision of Prof. Alan Bundy. He has been in computing at the computing department at Tecnologico de Monterrey, Campus Estado de Mexico, since 1985. In 2010, he was promoted to full professor in computer science, and in 2016, he has appointed head of the graduate program in computing in Mexico region at Tecnologico de Monterrey. He is member of the National Research System, CONACYT as well, currently rank 3, and fellow of the Mexican Academy of Science. He serves executive board of the Mexican Academy of Computing, and also former president of the Mexican Society for Artificial Intelligence. Welcome, Raúl. Thank you very much for being here.
Thank you very much for the invitation.
So, thank you very much. Thank you very much. So let's go to start with the talks. We have 10 minutes talks. We will present the 3 talks, and after that we will have the space for questions and answers. I hope we will have 2 rounds of questions for all of you. So if you agree, Virginia, we can start with your presentation.
Okay, thank you. Just a minute. Okay, can you see the presentation okay?
Yes. We will mute,
okay.
We'll mute our mics just to have a better sound for you, okay?
I'm sorry,
will
what?
mute my microphone, and I think all of us will do the same. Good.
Ah, okay, okay. Thank you. Okay. Okay, today I will talk about one of my research lines, my current research lines. I am working in this research line with other colleagues from the ITESM Research Institute. So in this research line, we focus the attention on the design of multi-objective autoscalars based on evolutionary algorithms for executing parameter sweep applications and workflow applications in public cloud environments. When I say public cloud environments, I refer to Amazon EC2, Google Cloud, and Microsoft Azure. Okay, these autoscalars that we have designed so far consider parameter sweep applications and also workflow applications mainly because this kind of applications represent many important computational applications in science, engineering, technology, and industry. Besides, these kinds of applications require usually a very important number of computing resources and a large amount of computing time. This is mainly because these kinds of applications are composed by many computational tasks that are resource intensive. So for all these reasons, these kinds of applications are suited for cloud environments and particular public cloud environments. Okay. Well, to schedule and execute these kinds of applications on public cloud environments, the autoscalars that we have designed so far consider the most relevant properties of this kind of environments in relation to the acquisition of instance of virtual machines. This is important because the applications are executed on this kind of instance, okay? In this respect, the autoscalars consider that public cloud environments provide access to instances of different types of virtual machines, always under a pay-per-use scheme. For example, in Amazon EC2, the users can access to instance at a fixed monetary cost for 1 hour computation. Okay? Of course, the instance of different types of virtual machines have different hardware and software configurations and different costs. So the execution of the task inherent to a given application depends on the hardware and software, the cost of the different types of virtual machines. So select the types of virtual machines to be acquired in this environment is a key problem here. The autoscalars address two interrelated problems in this context. The first problem is determining a scaling plan. This means determining the number and type of instance to be requested to the cloud provider. This instance will compose a virtual infrastructure on which the application will be executed. The second problem is scheduling the tasks of the application on the instance acquired according to this scaling plan. For this reason, are two problems interrelated. These two problems are addressed by the autoscalars so that optimization objectives predefined are met. This is very important. The autoscalars that we designed consider optimization objectives that are very relevant in the context of public cloud environments. In particular, the autoscalars are considering the minimization of the makespan, the minimization of the cost, and also the minimization of task failures that are inherent to unreliable instance. In some public cloud environments like EC2, the users usually can access to a spot instance that are cheaper than the regular instance, but are subject to sudden terminations by the provider. So the execution of the task can be impacted in a negative way. Okay, so this objective is relevant in the case of using this kind of instance. Well, these two problems that I mentioned are addressed by the autoscalars every 1 hour during the execution of a given application. This point is really important and is a particular property of these autoscalars. I will give more details about that in the following slide. The autoscalars that we designed have the general behavior that is shown in this figure. In particular, this autoscalar follows 3 steps. Suppose that we have an application to be executed in a cloud environment, and we know the optimization objective to be considered. So the first step In the first step, the autoscalars apply a multi-objective evolutionary algorithm in order to get a Pareto set of possible scaling plans. Okay, these scaling plans represent two different alternatives in relation to the number and kinds of instances to be requested to the provider. Okay, these scaling plans have different trade-offs between the objectives. In this, in the figure, we are considering only two objectives, but we consider the other objective that I mentioned before. Okay, in the second step, the autoscalars select the best scaling plan from the Pareto set obtained before, and this is made using a predefined criterion. Okay, this is made in a totally automatic way. In the third step, the autoscalars apply the scaling plan selected previously. This means that the autoscalar requests to the cloud provider the number and type and kind of instance detailed in the scaling plan, and then schedule the task on the instance acquired. Okay. In this point, it's very important to mention that the instance of virtual machines are acquired for 1 hour of computation, like in real public cloud environments like Amazon EC2. Okay. So when this hour ends, the autoscalars analyze if all the tasks of the application have been executed or not. If some tasks of the application haven't been executed yet, so a new autoscaling stage is started, considering the pending tasks. The three steps are developed again, and the check-in is developed again. So this is an iterative process that ends when all the tasks of the application are executed. Okay. Following this general behavior, the autoscalars can update the virtual infrastructure according to the workload of the application and schedule the workload on the updated infrastructure so that the optimization objectives are met. Okay. Well, the autoscalars designed so far were evaluated by computational experiments. We designed these experiments to evaluate the autoscalar in a very exhaustive way. We defined different autoscalars that have the same general behavior that I mentioned, but differ regarding the evolutionary algorithm used in the first step. Well, to evaluate these autoscalars, we consider different real-world applications. We consider different size per application. We also use different types of virtual machines available in Amazon EC2. In this way, we define different experimental settings that are very realistic. Well, in relation to the results, the autoscalars obtained excellent results in relation to all the optimization objectives considered by each one of them. Besides have outperformed autoscaling strategies previously reported in the literature, and this was really important. So the results obtained so far from the computational experiments have been really good. In relation to current and future research line, at this moment we are focusing the attention on the design and evaluation of other different new evolutionary algorithms to develop the step number 1 of the autoscaling process. And we also are analyzing the incorporation of other objectives in the autoscaling process. These are 2 points currently in progress. Okay. Well, to finish this talk, I would like to mention that we have published different papers inherent to this research line in the last years. And in particular, in this slide, I mentioned some of the papers published in the last 2 years. This year, we have an accepted paper in the Journal Scientific Programming that will be published very soon, I think. And we have also a paper accepted in the conference MICAI, the Mexican International Conference on Artificial Intelligence. So I think I will be presenting this work in October in the conference. And well, all the details about these autoscalars and the computational experiments that we have made so far can be found in this paper. So I invite to the person interested in these topics to review the papers. I finished my presentation, so thank you very much for your attention.
Thank you very much, Virginia. It's quite interesting. I want to remember to the public who is just attending this panel that the questions and answers will follow at the end of the third talk. So thank you, Virginia, again for your presentation. And Lourdes, your turn, please.
Okay. Can you see my presentation now?
Quite nice and clear.
Okay. Well, Dr. Michaela gave us an excellent keynote about how artificial intelligence is transforming healthcare. She definitely spreads her passion in this field, and in which I was already hooked on. I will present you some efforts we are making at Universidad Panamericana to develop some solutions in artificial intelligence for healthcare. So, as we know, AI research in health and medicine is increasing in the past decades due to the growing of computing power and the capacity of data storage. AI has been implemented mainly, for example, in disease diagnosis and prognosis, treatment and optimization and outcome prediction, drug development, and dealing with public health problems. But nevertheless, as we saw in Michaela's presentation, we say that implementing artificial intelligence solutions into healthcare problems is particularly challenging. Artificial intelligence and machine learning techniques can be self-improving and capable of identifying new patterns, but these techniques need reliable high-dimensional data sets. Clinical data sets are in different formats, in different varieties, and clinical data are also limited and with a potential bias sampling. They can be highly unbalanced with different ethnicities and comorbidities. So it's not very easy to in countries like Mexico, for example, in which we don't have reliable electronic health records as in other countries. And so it's also important that when we are gathering, we are trying to make solutions, we provide, it's not enough to have good models, we have to understand that a model has to be discovered and explained at the model and individual level to know what influences some decision. This is very important for the clinician. And so our solutions must be interpretable, explainable, accountable, and trustworthy. Michaela gave us a fine example of this in the COVID COVID solutions. So in this talk, in this small talk, I will try to present you some efforts we are doing in the Universidad Panamericana. We have two projects that are related to human activity recognition and fall detection, that is UPFOL model data set creation and the prediction of freezing of gate project. And another project that is working with genomic data, that is a methodology to determine the risk factor associated with complex diseases. So in the first project, we can see the following. Our goals are major public problems, especially for elderly people, that can sometimes remain lying a lot of time before receiving medical attention. Robust fall detection systems can prevent complications when fall occurs, but it's very difficult to have those robust fall detection systems. Our goal in the fall detection project was to contribute with a publicly available database for fall detection, because it's not, there's a lack of real data sets. So this was one of our goals. We analyzed different combinations of modalities in order to determine the positive effects of fall detection. We studied, designed different examples, and we reduced fall detections with dealing with these limitations. When we acquired, we used 17 subjects, young subjects, because it's dangerous to use other subjects, elderly subjects, that performed 11 actions, 5 falls and 6 activities of daily living, 3 sequences of each activity, and 3 modalities with wearables, ambient infrasensors, and cameras. We gathered more than 75 gigabytes from raw and feature data that is available for you to use if you want. And then we made a minimal fall detection afterwards. The best combinations and modalities to determine the positive effects of fall detection in order to make a realistic system that could be used in real scenarios. We found that the waist, trousers, and necks were the best, and the random forest. Then we deployed this model into an app which we generate the best model, so we could test with new subjects in order to simulate realistic conditions and see if it really works in a real environment. Everything you can see in our papers. Then another project is determining the factors of associated diseases. We studied the process from the first blood sample recollection until presenting good interpretable solutions, and we tried our solution with age-related macular degeneration genomic data. Our study designed by genetic variants, the selection, extracted the DNA, phenotyping, the database construction, and the machine learning analysis. We encountered data of balancing. We have to make the solution interpretable and explainable at different levels. But we found some interesting association of polymorphism of AMD for the clinicians. So we are happy about it. The last project is the prediction of freeze of gait detection. Freezing of gait is a phenomenon that happens in patients of Parkinson that stand and can go forward in foot progression when some happens. So it is important to predict if this freezing of gait will occur, because it increases the risk of fall occurrence, and it's the main reason of loss of independence and impairing the quality of life. It's a lot of work done in detection of freezing of gait, but it's very little work done in prediction of freezing of gait. So we're now currently working in this important health problem. This is our research team. We are 4 researchers, doctoral students, master students, and some bachelor students. So thank you for your time.
Thank you for your presentation, Lourdes. This is quite interesting. And let's gonna start with Dr. Raúl Monroy as well. So Raúl, please.
Yeah, can you hear me?
The floor is yours. Yes. Of
Okay,
course.
good. Brilliant. So, okay, so I hope you can get to see my presentation. Rather than talking about my own research, I would like to describe a little bit the research carried out by a research group in Tecnologico de Monterrey called Machine Learning Models. Our group, yeah.
Sorry, Raúl. We back screen. I don't know if it's correct.
What about if I do that? That would be,
No.
is that working okay? No?
No. Maybe if you turn it off and turn it on again.
Oh.
There. Okay.
What? Can you get to see that now?
Yes.
And if I put it there this way?
No, maybe it is going to another screen.
Yeah, possibly. I'm not very sure about that. Let me see if I can get to see the, because now that I have shared my screen, I can get to see the application panel actually. So which is, that's a little bit surprising though. Sorry about that.
It's
Yeah,
still.
I can't get to see the.
It is still a PowerPoint presentation. Maybe if you put it.
There you go.
Okay.
Yeah, let me try to put it this way. Let me see. Aha. No, I can't. I'm sorry, but I can't make it. I can't make it work. The menu, the bit about what slide I'm sharing, I cannot even. Can you take control of the video, Miguel?
Let me check. No. If you click again the screen icon.
Yeah, that's what I'm doing. But it is off. The thing is that the screen icon is disabled. Yeah, I cannot do anything.
Maybe Jennifer can support us. But if you wanna, just in the interest of time,
yeah,
if we can
now,
just proceed like this, it will be
okay.
nice.
I will proceed like this, right? So you
Okay.
can get that, right? Okay. So sorry about the size of the presentation, but as I was saying, so our group is distributed. We have people in 5 cities, namely Toluca, Querétaro, Puebla, Guadalajara, and the city of Mexico. We are 9 members, full-time, faculty staff. And as I was saying, our group develops spans in quite a number of areas in machine learning, in particular classification, data mining, clustering, and process discovery problems. And in particular, we also develop some visualization modules that we apply in the context of data science. We have developed, as I will show you later on in the talk, a model that is capable of representing at the same time almost 20 different variables, which is good for the user. But we also have developed data sets for the benefit of the community. And mostly our applications have been in the context of cybersecurity, health, but also in a bit or in an area that is related with cybersecurity, but is mostly about biometrics, and in particular, latent palprint and latent fingerprint for identification. This slide is trying to convey in a very single, in a simple shot, say the main application areas in which our group has gone through. In particular, we have used anomaly detection in the context of cybersecurity for the timely discovery of ongoing DDoS, that is distributed denial of services attacks to different kinds of servers, including the DNS. We have also applied anomaly detection to masquerade detection, bot detection, especially political bot detection, business process management, and of course, as you could see in my first slide, Miguel González, a member of the group, who is the moderator just now, he works on, in particular, in video surveillance, but other different projects. We have also projects related with wildfire detection and crowd counting, using, of course, deep learning. Just to give you a glimpse about the kinds of things we do, I will present two pieces of research. And one of them has to do with creating a new technique for doing better machine learning. And the other one is just an application of the techniques that we have developed in the group. So in the context of clustering, basically, as you know, a clustering algorithm, you give that algorithm an input, sorry, a collection of data, and then that algorithm will output a set of clusters. And in many contexts, you would like to evaluate how good that group of clusters is. And to have a look at, or to understand, to grasp the main idea that we were exploiting in this particular piece of research, I will recall you what the classification problem is. But first, let me tell you that standard techniques in the literature would use two particular properties in order to evaluate a group of clusters, namely separation and compactness. That is, how similar members of a group are and how dissimilar different groups of the group of clusters are. In our work, we approach the problem in a different way. Actually, it is much more based in a heuristic concept. So in order to grasp our technique, let me just first remind you a little bit about the classification problem. So as you know, the idea of a classification is to build a decision model such that when input a set of data divided into a set of classes, if we are given a new observation, we would like to identify to which of these classes that observation belongs to. For example, in the context of binary classifier, then you will have this set, say, two different classes, each of which contains several members, and you aim to build this method that when it is input a new observation, it will tell you which of these two classes the object is more likely to belong to. So in our technique, the idea is just as follows: it's heuristic based, as I said. So if you give me a good group of clusters, then that group of clusters should be enough to allow me to build a classifier that has a very good classification performance. That is, it is able to easily discern objects from the clusters provided in the group of clustering. And in that case, I can not only build a single classifier to avoid bias, I can build actually a number of classifiers of different nature. So if these all classifiers provide to me a very good classification performance, then I would say that the clustering was not that bad. Actually, it was very good. And this piece of work is very simple. It is based on a very simple heuristics. And this is to show that very simple ideas sometimes make it go through to a very good publication. The project that I will describe next is in the context of personal risk detection. I'm not going to give you the details of the pictures that you can get to see in the slide, but the general idea is that you can think of a subject of a study, say an elderly person, and he's wearing a smartwatch, say, and from that smartwatch, we can read sensors. We build this particular visual model that allows us to have a look at almost 20 different variables at a time. That can be good, for example, for someone who is watching over this guy. But we also built a one-class classifier for the detection of anomalies in behavior where we understand behavior by the readings that you can get from the sensor, or I would say the network of sensors. So with these two different projects, I complete my talk. Thank you, Miguel, for the time. And sorry, I took a little bit more and longer.
Thank you very much, Raúl.
Thank you very much, Raúl.
It's always a pleasure to have panelists who are very timely on time. I really appreciate that. So let's gonna start with some questions. I don't know if we have some questions from the crowd. If just waiting for some of these questions, I think just concerning the role of artificial intelligence in the development of science, particularly not only science in general terms in other areas, but also artificial intelligence as a science itself. So the development of AI as a catalyzer of development of artificial intelligence, science in general, and engineering application, as you show, we of course can develop or to push forward, or to push the borders of the knowledge. So, your experience, how can you manage the development of new artificial intelligence algorithms, methods, and also to push the frontiers of a particular area, for example, health or cybersecurity, and then, of course, to arrive to get concrete solutions on these challenges? Who wants, maybe Virginia, do you want to comment about it?
Yeah, I don't know if I understand your question concretely. It was long, but but in general, when we address a problem, we usually think in the problem in an abstract level in order to define solutions that then can be applied to different areas. Okay. For example, I don't know if your question is about that, but for example, in the topic of cloud computing, when we design solutions, we think in terms of, okay, different kind of applications that represent to many other concrete applications, and then these solutions can be applied in different domains. I don't know if you refer to that. We work in this sense, okay, considering different possibilities to apply our solutions in artificial intelligence.
Yeah. Okay. So for you, first, you search for concrete challenge. For example, in this case, in cloud computing, of course, you use your experience, your expertise, just to push forward for a new solution or an innovative solution. But again, maybe this expertise can on artificial intelligence itself with new algorithms. That's a bit of the question. And
sorry, Miguel.
I'm sorry, the sound is bad. I don't listen to the question.
Yeah, sorry. Just to have symbiosis in the development of new solutions. Yeah, I'm sorry. Maybe my internet is not so good. So I will get more concrete. Yeah. Maybe we can pass to Lourdes. What is your opinion about the symbiosis, the development of new solutions in the challenge of, for example, engineering, but also in science?
We have seen in different international conference and in different places that techniques and the science of artificial intelligence is mature and towards providing good solutions. But I have seen that one of the things that are most important now is the ethical issues in order to provide these solutions into the real in the real conditions, because we have to see that it is important not only that we have good models, as I said, but we have to provide this in a robust manner, correct models. Micaela told us this same thing in the morning, that we have to have good models, good solutions, but reliable and trustworthy. This is, I think, a big issue that makes people to be scared of using these solutions, mainly in the healthcare area, for example, or finance area, where consequences are very bad if it's not robust. So I think that in order to take our research and develop realistic solutions, we have to work in these issues so people can rely on our solutions.
Quite nice. Thank you, Lourdes. Raúl, maybe you can comment something? Just the time to pass to this following question.
Sure. Yeah, I think that doing science and artificial intelligence, or doing research on artificial intelligence, is in general, conducting some kind of search of a space of methods. And sometimes it is doing, searching in a space of configurations, architectures, or whatever, for example, in the context of deep learning. And of course, the more knowledge we have in a particular technique or a set of techniques, the more likely we will be successful to find a solution to a problem, or even to find an innovative solution to a problem. Sometimes it is good to have or to discover new applications of a technique. And I believe that's an important thing to bear in mind. Thank you, Miguel.
Here we have another question. Maybe it's also concerning all the challenges we have in engineering, especially because of the importance of, for example, here Atocha Aliceda asked if you can comment also on the data collection, quality, good data sets, and of course the importance and challenges we have here, because right now we have not only technical issues, but also ethical or some other issues like privacy. So do you want to comment something about it? Sorry, is it clear?
Yes, perhaps.
Can you hear me?
Yeah, we got the question, but we don't know
something about it.
Whom you are.
I think there is a lot of data out there. We are all generating a lot of data daily, but as you say, it's not always good quality, and it's important not to encourage some malpractices that incur in privacy issues. No, in healthcare, especially, for example, is easy because, as we know, it's very difficult in different ethnicities, in different formats. But this problem is in general. We have a lot of data, but they don't interoperate well as easily as we could. And some data sets that are gathered, good quality and everything, are not publicly available. So I think we have to be generous and make good data sets and make it publicly in order to enable the comparison and the advancement of all of us. No, this will help us. But in the health area, it's very difficult because some data are not so easily shared because they are very sensitive. No, so I think we have a lot of work to do in this area.
Yeah, I do agree with Lourdes. I think that in general, data collection as a paper review is a very noisy process. And we actually striving towards building methods that are capable of dealing with that kind of, inconsistencies, and noise, uncertainty, and so on and so forth. And so I guess that there's still a very long road ahead to travel and to go through in order to come out with methods that are robust enough to that kind of data that we are given by any collection, any data collection process. Of course, the better the data and the more the data, usually the better your prediction. And well, basically that's what I wanted to say apart from saying hello to
thank you, Raúl. Just asking for to the public, we have still time for one. Virginia, do you want to complement a bit
about this question? Yeah, I am thinking that in some communities, like online social networks, the community is working very hard in relation to data. All of them work together to define good data sets and politics to get these data sets. And I think in the community of artificial intelligence, we should take the same in different areas. When you think in techniques of data mining or machine learning, okay, we have very good data set, very well known, but thinking in a future worlds, I think this is a communitary work, it's not an individual or groupal work, I think. So this is very important that all the members of the community work together in order to get good data set, to guarantee the quality and all of that. Okay. It's a communitary work.
Yeah, of course. Do we have another question over there? I think it is not. Okay. Just a comment, for example, here, just coming from challenges. Problems in engineering having data sets, it means maybe from batch tasks, and all the others are real-time data, or the several challenges. It could be sound, video, and some other kinds of data. To work in these two extreme paradigms poses, of course, several challenges in your domain areas. Could you maybe add some elements, key elements, just to work on batch with good data sets, batch tasks, and on the other way, or to work in real-time applications represent some other challenges. So can you explain a bit on your own domains, please? Maybe Lourdes?
As we can see, models have a high precision, for example, when we train them offline, no? But you have to be able to deploy those models and try them in the field, no, in the real scenarios. And this is very difficult. And as I have searched for related work in different areas, you can see that many researchers stay in the offline model and just present those results. We saw that and we tried to make some online testing. It is important that you make your models and you prove your models and evaluate them with the real conditions, because no solution is not those the few works that I saw that did that, was they have very low resolution, very low accuracy. So you have to make more efforts towards that, because else we will not going to be provided a real solution to the problem.
Virginia, do you want to comment a bit?
I am relating your question to the area of cloud computing and the data, all of that. And we think in the research group, we usually, when we define it, for example, these autoscalers for cloud computing, we need to evaluate these techniques regarding data sets from commercial cloud environments, like Amazon EC2, for example. So the data set that provide from them are essential to evaluate our techniques, to evaluate the integration, the possibility of using an autoscaler on a public cloud environment. In this sense, well, we have hard difficulties sometimes to get these data sets. But, well, it's a challenge in our area, for example, about data sets, a very important challenge. But we need to work with this challenge every time to test when you have new techniques, and that you need is integrate these techniques with a commercial environment, you usually find these challenges about the data sets. Okay.
Quite useful.
Yeah, well, let me just say a few words about a typical problem in the context of cybersecurity. Suppose that you would like to get to have one process in your mobile running all the time in order to detect the presence of malware. That's basically a classification problem. But the input data actually comes from the source of information comes from a collection of processes, that is individual applications running in your mobile. And the behavior of these processes changes over time. And hence this source of information has this particular behavior pretty much like a time series, where a reading may depend on a previous reading. And then the challenge is trying to detect whether some particular behavior corresponds to a malware or not. And of course, you wouldn't like to switch off a particular application that the user is fond of, right? So in that case, you have this big problem, because you are trying to timely detect the presence of malware, because you want to know just now whether you have malware in your system or not. But also you have to deal with a source of information. The behavior of it changes over time. And it is basically like a time series. And that's very difficult problem.
So we are approaching, we have only, let me see, we have 5 minutes. Maybe you can express some closing remarks, 2 minutes for that. Virginia, do you want to close with some remarks, 2 minutes remarks on your talk or the discussion?
Okay. Yeah, in the session we can see different areas, every presentation in different areas. But I think the most important is in this session, and I can see other sessions too today. In every session, we can see the relevance that have the artificial intelligence techniques in different domains. Today, artificial intelligence is in every day, in every work, in every company, in every organization. So I think that this is important if the researcher and professors I think we should encourage to the students to specialize in artificial intelligence. And I can say this is the more important for me because all the companies in the world are using artificial intelligence to improve all the solutions. So if we can say some important today, I think this is okay. We are working in different artificial intelligence areas to solve different kind of problems, and all is about artificial intelligence. So please specialize in artificial intelligence, and this is a
Thank
good
you,
way.
Regina. Thank you very much. Please.
Yes, I agree that there's a lot of expectations of what artificial intelligence can do for us. We have a lot of opportunities, but we have, as I concur with Virginia, very little people, well, few people that are working in this area. We say, as you know, we see many of them in the same conferences, in the international conferences, but we need to encourage young people and women in particular. This is my special treatment, to join this domain, so we can really leverage artificial intelligence and work in ethical issues in order to enable these solutions to be in real problems. No? So it gives solutions to real problems.
Lourdes and Raúl, last but not least.
Well, I guess, yeah, I guess my final remark is that all those challenges that Lourdes and Virginia have pointed out, and the need for you guys to join us in this particular enterprise, then, well, do that, either at Buenos Aires, la Universidad Panamericana, or Tecnologico de Monterrey. No better than that.
Thank you very much.
Okay,
So just closing this panel, I really appreciate your participation, Virginia, Lourdes, Raúl, and also to thank the organization. Jennifer, she is doing extraordinary work. All the Leobardo, who is also on the as well as a co-host. Thank you very much, and let's continue with the program at RIA. Enjoy. We have still a quite nice program, and that's it. Thank you very much. Thank you. Thank you. Bye bye.
Bye. Thank you.